Hello everybody. This is a practice problems video for you on sampling distributions. A lot of you have told me that after going through notes, it's helpful for you to see other practice problems and just see more things worked out. So that's what I've done for you in this document right here. So there are 5 sampling distribution problems for you on this document. Some of them are proportions and some of them are means. I'm going to do the first 2, right, the ones on the first page here, and then I'm going to have you pause the video if you're kind of following along with me here and try the other 3, and then check back with me to see how you did, right? So let's go ahead and jump into this one, right? I put some tips at the top for you and some good steps to help you solve these types of problems, okay? So first thing is always check to see whether the data is categorical or quantitative, right? So categorical data, you're going to be dealing with proportions. Quantitative data, you're going to be dealing with means, okay? Calculate the mean and the standard deviation. Check your conditions. Sketch the normal curve. And then write your answer using the probability notation, all right? So let's go ahead and jump into this here. So for this first one, we have, suppose the proportion of bats that live under this bridge is 15, that have rabies is 15%. Okay, so that is my population proportion, P. Okay, they said 70 bats are selected at random. So 70 is my sample size. Okay, and then they want to know what's the probability that the proportion of bats in the sample is more than 25. Okay, so 25% is our P hat value, our sample proportion. Okay, so first thing, I know that I'm dealing with proportions here, so let's do the mean and standard deviation. So the mean of my sampling distribution of proportions is equal to the population value. Okay, the population proportion, which is 0.15. My advice is, if they ever give you proportions in percentages, go ahead and convert them to decimals right at the start. It makes doing the math a whole lot easier. Okay, next, standard deviation. So standard deviation of the sampling distribution of proportions is P times 1 minus P over N. Okay, that's your formula. So for this one, it's 0.15 times 1 minus 0.15 is 0.85, all over the sample size, which is 70. This 7 looks kind of crazy, but 70. Okay, I just plugged all of that into my calculator and I got 0.0427. Okay, so I'm going to check my conditions really quickly. So my first condition is the randomness condition, which we're good there. It's stated in the problem. Okay, second condition is my independence or 10% condition. Easiest way to check this is by doing 10 times the sample size. So that's 700. And I'm going to say that that's less than the total number of bats. Okay, that could possibly live under that bridge. That's a reasonable statement to make. Okay, and then my third criterion, my third condition here is my success fail condition. Okay, so remember you do that by doing the sample size times the population proportion. So 70 times 0.15. Okay, and that's 10.5. And the goal is we want that to be greater than or equal to 10. Okay, and then we do the same thing with the number of failures. So 70 times 0.85. Okay, is 69.5, or sorry, not 69.5. 59.5, which is greater than or equal to 10. Okay, so those are my conditions. All right. Okay, so now that I've checked my conditions, what that means is that this sampling distribution is approximately normal. Okay, which is lovely, right? That's what we want. Okay, that's what we want. So now I can go through and use all of my normal distribution tools. So I'm going to do a quick sketch of my normal distribution. So my mean here is 0.15. My standard deviation is 0.0427. Okay, and then I'm concerned with that a sample that has more than 25%. So here's 0.25 and it's more than, so I'm going to shade above. So what I'm trying to find is the probability that p hat is greater than 0.25. That's the goal. So in order to do that, I'm going to calculate my z-score. Okay, so remember, z-score is always your data point, which is your population, not your population, but your sample proportion. So that's your data point. 0.25 minus the mean, 0.15, divided by standard deviation, 0.0427. Okay, and when I did all that, I got 2.343. So once you get to this point, you can either plug that into your calculator using normal CDF, which honestly I recommend you do if you're dealing with a greater than proportion. It can be a little bit easier than using the Z table, but you can also use the Z table if you wish. Okay, just remember that the Z table will only give you areas to the left of a certain value, right? So if you're finding a greater than probability, you got to do some subtraction, right? Subtract from 1, use that complement rule. Okay, so here, if I'm finding the probability that p hat is greater than 0.25, that's the same as the probability that z is greater than 2.343. And then I did this in my calculator and got 0.0096. So a very, very small probability that I get a sample proportion that extreme. Okay, now of these that I've written here with the probability notation, just a reminder, you don't really need both. Okay, you could write one or the other, and that would be perfectly acceptable. Okay, all right, so give me just a second. Let me clear my screen off. Actually, no, I think I should just be able to. No, I'm just going to go ahead and move this up. Okay, so there was a proportions example for you, and then I want to do a means example for you before I give you a chance to try the third, fourth, and fifth problem on your own here before checking back with me. Okay, so let's look at number 2. So number 2 says we have a hot dog manufacturer, and they're claiming that the average fat content is 18 grams per dog. Okay, so that is my population mean. Okay, they're saying consumers of this brand would probably not mind if the mean is less than 18, but they might get upset if it's actually more than 18, right? So they wouldn't mind if they were eating less fat, but they would get upset if they were eating more fat and the company was like lying to them about it. Okay, so they say suppose standard deviation is 1 gram of fat. So that is my population standard deviation. Now remember, there's a key difference between this process for means and the process for proportions. For proportions, the only thing they have to tell you to be able to complete the problem is the population proportion. That's it. Okay, but for means, they have to give you the population mean and the population standard deviation. Without it, you can't use the formulas and you can't solve the problem. Okay, all right, so the last little bit of this here says an independent testing organization is asked to analyze a random sample of 36 hot dogs. So 36 is our N, our sample size. Okay, and they find that their sample mean, X bar, is 18.4. So that is my data point, X bar, or my sample mean. Okay, so the question is, does this suggest that the manufacturer's claim is incorrect? So what we're going to try to find here is how likely is it that I get a sample mean that extreme, so 18.4, or higher, right? I put greater than or equal to here in my probability notation, you could just put greater than. That would be fine as well. Okay, so first thing is I need to do my mean and standard deviation. So the mean of my sampling distribution is equal to the population mean, which is 18. Okay, and then for my standard deviation of the sampling distribution, you take the original population standard deviation, which is 1, and divide it by the square root of n, which is 36. So this is 1 over 6, which if you round and convert it to a decimal, which I recommend that you do, is 1.667. Okay, so there's your mean and standard deviation. Okay, then I need to check my condition. So my first condition is randomness, which that is stated in the problem. Okay, 2 is your 10% condition. So I'm going to do 10 times the sample size, which is 36. That gives me 360. And I'm going to say, yeah, that's definitely less than the total number of possible hot dogs. Okay. And then my last one, 3, this is the condition that changes from means to or from means to proportions. And that 3 looks crazy. Let's write that again. Okay, so this one is based on your central limit theorem. Okay, so remember the rule is either you have a normal population or n has to be greater than or equal to 30. Okay, so in this problem, they did not tell us that the population was normal. So you cannot assume that the population is normal. But lucky for us, okay, our sample size is 36, which is greater than or equal to 30. So we are all set on all 3 of our conditions. And I'm going to kind of block our conditions off here. All right. So once we have all of our conditions satisfied, that means that we can use all of our tools for normal distributions, z-tables, z-scores, normal CDF, all that fun stuff. Okay, so here I'm going to draw and sketch out my normal curve. So my mean is 18. My standard deviation was 0.1667. And then my data point is 18.4. And I'm trying to find what's the probability that I get a sample size or a sample mean greater than that value, right? Or more extreme than that value, okay? Because that's what they noted in the problem. They said that we don't really care if the mean is less, but we would be upset if the mean is more than 18. So what we're trying to prove here is with this sample, say, okay, we're going to assume that this is true. We're going to assume that they're telling the truth about the fat content of their hot dogs, right? And if we're assuming that that's true and we get a sample with a mean this extreme, how likely is that to occur if this is the actual true population mean? Okay, if we get a probability that's really, really small, what that means is that this value, the mean that they reported, probably is actually not true, right? Because the probability that we get here when we calculate our z-score and plug that into our calculator or use the z-table, that probability is how likely that particular sample value is to occur. Just by the random chance and the random variation of the universe, right? So if that is highly unlikely, then that means we're probably operating under false assumptions. Okay, so this is a way that we use statistics to evaluate claims that people make and basically determine if they are being truthful or not. Really cool that we can do that with math. Okay, so let's go ahead and calculate our z-score. So I have z equals, remember it always goes data point first, so 18.4 minus the mean, 18, divided by the standard deviation, 0.1667. Okay, when I plugged all of that into my calculator, I got, whoops, hold on. It got cleared off of my calculator. Terrible. Okay. So I ended up with 2.3995. So I'm going to round that up to 2.40. All right. So now I'm finding, again, you can either write this probability notation or you can write this probability notation, probability that z is greater than 2.40. Okay, and the number that I got there when I plugged that into my calculator was 0.0082. So there's a less than 1% chance, if 18 really is how many grams of fat on average that are in these hot dogs, there's less than 1% chance, just by the natural variation of the universe, that I get a sample mean that extreme. So the question is, does this suggest that the manufacturer's claim is incorrect? Yes, it does, right? So yes, right, this sample mean is too extreme, i.e., you have a really low probability to occur by chance if the true mean is 18 grams. Okay, so you've seen a mean example and a standard deviation example. Okay, there are 3 more problems. Okay, there's 3 more problems here, right? And so what I would love for you to do is give these a try. Okay, give these a try on your own, right? And see if you can follow the steps and figure out the correct answer. Okay, I will tell you that 2 of these are proportion problems, and 1 of them is a mean problem. Okay, so I'm going to go ahead and pause the video. I suggest you do the same. Try these other 3 problems out and then check back with me to see how you did. All right, folks, so let's take a look at these solutions here. Okay, so I'm going to let you know I did not check the conditions for all of these. I just did the math, but if you're curious, if you checked your conditions correctly, send me an email, send me a message, let me know, and I'm happy to verify them for you. Okay, so this first one that I had you do on your own, number 3, is a proportion problem. So they say 22% of American children under the age of 6 live in households with incomes less than the poverty level. So that 22% is my true population proportion. So that's my mean, right? When I'm doing my z-score. Okay, they said a random sample of 300 children, so 300 is your n value, are selected, and they say what's the probability that 80 or more live in poverty. So now here's the deal. They did not give you the sample proportion. You had to calculate it. They gave you the number of successes out of the total, so you have to calculate it. So that's what this is here, right? So I did the number of successes, 80, divided by the total number in the sample, 300, to get my sample proportion of 0.267. Okay, then I used my population proportion as my mean, and then calculated my standard deviation, right? You can see the work here, and I got 0.0239 when I did that. So then I'm going to go ahead and throw that into a z-score. So remember, it's always data point, right, or p hat minus the mean divided by the standard deviation. So that's what's happening right here. Okay, data point minus the mean divided by the standard deviation. So my z-score ended up being 1.965. Okay, so what I'm trying to find is what's the probability that 80 or more. So, and I obviously did not draw the normal distribution part out here, but you could have, right? It would have looked something like this. You have 0.22, 0.267, and you're finding a greater than probability. I realize that a lot of these are greater than probabilities. Sorry about that. I probably should have provided you with a little bit more variety, but nothing can be done about that now. So what I'm finding here is the probability that I get a sample proportion of 0.267 or higher, right, or more extreme. How likely is that to occur, right? And the probability that I got was 0.0246, so very unlikely, okay? It's very unlikely that we get a sample where you have 80 or more children in that sample living in poverty. So if you do get that kind of a value, then that means this value, the 0.22, probably is not the actual, like, true proportion of the population. Okay. All right, let's look at number 4. So number 4 is we're talking about temperature in a power plant. Okay, and they give you the average temperature. Okay, so that's my mean, and they give you the standard deviation is also 5. Okay, and then they say for 50 randomly selected days, so that's my sample size, they want to know what's the probability that the average increase in temperature is greater than 5.2. So 5.2 is my X bar, right? And then I have my mean, my standard deviation, and my sample size. So the mean of my sampling distribution is equal to the mean of my population, which is 5. Standard deviation is standard deviation of the population divided by the square root of n, which is 50 in this case. So I got 0.707. Plug that stuff into your z-score. So data point X bar minus the mean divided by the standard deviation. So my z-score was 0.283. And I'm trying to find how likely is it that the increase is greater than 5.2. So that's what I'm finding right here. Right? Again, I didn't draw the normal distribution, but you could have drawn the normal distribution here. I typically recommend you just do a quick sketch for yourself to make sure that you're finding the correct probability and that your answer makes sense, right? They also will give you points for it on the AP test. Okay, so, oops. So if you drew the normal distribution, your mean was 5. I have 5.2 right here, and I'm finding a greater than probability. Okay, so whether you did it with the actual X bar value or if you did it with the Z value, you should have gotten 0.389, so around 39%. Okay, so that's a reasonable probability, right? That would not be enough evidence for me to reject a claim or say that the claim made by that water heater company or that power plant was not true. Okay, usually we need the proportion to be really, really small. Like the probability that we get has to be really, really small, like usually 5% or less. If we want to be skeptical about the claim made by someone about the true population value. Okay, so that's number 4. And then just as a reminder, you do not have to write out both the X bar probability and the Z probability. You can pick one or the other. And just know that you can do the X bar probability directly in your calculator without having to calculate the z-score. Normal CDF will do that for you on the fanciful calculators. You just have to remember to enter the new mean and the new standard deviation. My advice is to just do the z-score, right? Because it shows that you kind of know what you're doing. You're going to get more points, or you're more likely to get points on the AP test unless just in case you screw something up or you plug something into your calculator incorrectly, you're more likely to get more partial credit if you calculate the z-score and show the normal distribution sketch, rather than just like plugging it into the calculator. You're also less likely to make a calculator mistake if you do the z-score and then just enter that z-score as either your lower or upper bound. So like in this case, the z-score would be the lower bound. And then remember, you just put like a bunch of 9s for the upper bound. If it's the other way around, so if you're shading this way, that your lower bound would be like negative with a bunch of 9s. right? And then your upper bound would be whatever your z-score was. Okay. So just keep that in mind if you're plugging stuff into the calculator. I think it's easier to do this, and you're less likely to make mistakes by having to enter more data if you're going to use this and like not convert it to a z-score, basically. Okay. All right. So last one was another proportion problem, obviously about the zombie apocalypse. So they said during the beginning of the apocalypse, the proportion of zombies in Texas is 0.68. So that's my population proportion. Okay, and then we have a random sample of 32. They want to know what's the probability that at least 75% of them will turn into zombies. Okay, so my mean of the sampling distribution is the population proportion, 0.68. I plugged my population proportion into my equation for standard deviation and got this standard deviation, 0.0825. Again, I did not draw the distribution, but I could have. I also didn't check the conditions. But I'll just tell you they should have been verified for all of these. Okay, so my mean is 0.68 and my sample proportion is 0.75, and I'm trying to find what's the probability that at least 75% will turn into zombies. So that means 75% or more will turn into zombies. So again, all of these ended up being greater than probabilities. Not sure how I managed that one. Sorry about that. But by the end of this video, y'all will be really good at the greater than probabilities, right? So here I'm finding my z-score. So remember, it's data point minus mean divided by standard deviation. So I got this z-score right here, right? I'm finding the probability that p-hat is greater than, I'm saying greater than or equal to. You could have put greater than, that also would have been okay, of 0.75. And when I plugged all that into my calculator, I got 0.1977. So if you round up, approximately 20%. So the probability that you'll have at least 75% of this sample being zombies is about 20%. All right. So that is it for this video. I hope you found this helpful and informative when going through and doing sampling distribution problems. So I will see you all in the next video, which will be in the next unit. All right. Bye, everybody.